Hi, in this video I will show you a way of deriving the formula for the circumference of a circle. A circle of radius r has circumference given by c equals 2 pi r, where pi is approximately 3.14. Now let's see where the formula comes from. First, consider the yellow circle that circumscribes a red equilateral triangle, each side of length x, and the center of the circle has radius r, and each angle of each of these smaller triangles is 2 pi on 3. Crudely, as a first approximation, the circumference of the circle is the same as the sum of the three sides of the equilateral triangle. In other words, x plus x plus x, which is 3x. We can work out an expression for x in terms of the angle and the radius by applying the cosine rule. Cosine rule applies to any triangle where you have an angle theta between two sides, and this is the formula that relates the three sides of the triangle and the angle. If we compare one of the smaller triangles on the left to the triangle for the cosine rule, we see that C is the same as x, A is the same as r, B is the same as r, and our angle is 2 pi on 3. Now we substitute those values in our formula for the cosine rule, and this is what we obtain. Simplifying that, and then taking out a factor of 2r squared, we obtain the expression shown here. And then finally, to obtain x from x squared, take the square root of the right hand side. Now our circumference is 3x, so that means using our expression for x, our circumference is 3 times that, as shown here. To obtain a more accurate approximation for the circumference, instead of using an equilateral triangle, we can use a square, each of side length x, and each angle is 2 pi on 4. The approximation for the circumference now becomes 4x. Again, we apply the cosine rule to obtain an expression for x. There it is. And then our approximation for the circumference 4x will become 4 times the right hand side here. Now how about we try a pentagon in exactly the same way. Each side is of length x, but each angle now is 2 pi on 5. So our approximation for the circumference is 5x. Again, applying the cosine rule, we obtain an expression for x. There it is. And then 5x becomes, as you can see there. Let's summarize what we found so far. For 3 sides, the circumference becomes that. 4 sides, 5 sides. Do you notice something? The numbers in red are the only values that are changing, and they represent the number of sides of our approximating shape. So that means for a shape with n sides, this would be the approximating circumference of the circle. Our next step will be to obtain an expression for 1 minus cos of 2 pi over n. And to do that, we use what is known as a Taylor series expansion involving the cosine of the angle. In general, cos theta as a Taylor series expansion is an infinite sequence of terms, as you can see there. The so-called exclamation marks in the denominator of each term really represent what we call a factorial. And this is what they are defined as. 0 factorial means 1, 2 factorial is 2 times 1, which is 2, 4 factorial is 4 times 3 times 2 times 1, which is 24, and so on. 6 factorial is 720. So making those substitutions, we have our Taylor series expansion to be what we have here. Now we can substitute for our angle theta, which is 2 pi over n. So substituting 2 pi over n in our previous expression, we obtain cos of 2 pi over n to be equal to what we can see here. We can rearrange that to get an expression for 1 minus the cosine, and it looks like that. Now we can make this a bit easier to understand by taking out as a common factor from each of these terms on the right, all of that. And that's what it looks like. In our final stage, what we're going to consider is what happens to each of these terms as n, the number of sides of our approximating shape, becomes larger and larger. What we'll see is that each of these terms becomes smaller and smaller, so that we can basically assume that they approach 0. They are negligible. And to show that, we say let n approach infinity. So that means each of those terms that we had in the previous screen becomes 0. And this is our expression for 1 minus cos 2 pi over n. And that simplifies to what we can see here. So in our general solution for the approximation to the circumference, we can substitute for 1 minus cos 2 pi on n the value 2 pi squared over n squared. And that's what it looks like. Simplifying what's inside the square root, we obtain 4 pi squared r squared over n squared, and that simplifies to n times 2 pi r over n. And then cancelling out the n, we have our final value that the circumference of the circle is given by c equals 2 pi r. I hope this gave you some appreciation of the importance of Taylor series expansion, and I encourage you to investigate their application at greater depth. Until next time, bye bye.